So nothing from homework. Homework is great. I'm glad I got some more. That's good. Okay. So last thing we did was the box plots. Let's do a quick little review problem of box plots. Let's see if you're working. Sort of, okay. All right. Let me make up some data. Sure. Poor little dude. My memory is really bad. I've left all my markers in some other room. So how do what goes into making a box plot? Let's see, it's been just a little while since we last talked about this. Over a week.
I don't think we talked about it.
We talked about 5-number summary.
We talked about stem leaf plots.
Stem leaf plots,
And
sure.
percentiles.
Percentiles. And we talked about quartiles. Yes. And the very last thing I did at the last class, believe it or not, was constructed a box plot. So it's okay if you forgot. It's been a little while, but we did. Yes?
That's the one where you do the highest and the lowest.
Yes. All right. So 5-number summary. Yeah, it's a good thing we're doing a review problem, isn't it? It's crazy how there's a method to my madness. Or madness to my method, one of those. So like you said, the 5-number summary is the lowest, the first quarter, the second quarter, the third quarter, and the highest. That sort of makes sense. Okay, on. So one way to summarize the football game is, well, we started off with really good expectations. At the end of the first quarter, we were down by 20. And the second quarter, we were down by 40, and then just keep going. Then somehow we lost. So the low and the high are easy as shit. I mean, the lowest is 11, the highest is 56. What's really nice about the data I gave you that you must be true is, of course, the data must be in order, or else percentiles don't mean shit, because then you can just put whatever number you want to wherever you want it to be. That would be a form of lying. Right? I know some officials are making it okay to lie, but we know it's not. How do I do Q1? What's another name for Q1? Q1 is the first quarter, which is what percentage of the way in? 25%. So it's another name for P25. What are the two steps to figure out what the hell that is?
25 or 10%?
25% of?
10.
I don't know. Did you count? Are they 10?
No, never mind.
I don't know. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Thank God. I was hoping there wasn't 10. Why was it 10 the one time we did it? Why was it 10? Because there were 10 data points. So what sucks when we do an example as teachers is if there's something that's true for that example, it's not always true. So it's not always 10. Bless you. So if I gave you 18 data points, you would do 25% of 18. If I gave you 3,400 data points, you do 25% of 3,400, whatever I said. So 25% of 11, somebody help me out. Somebody help me out? 2.75? Yes? What do I do with that shit?
Round up.
Good. So it's either, if it's a whole number, you average that one with the next one. Yes. So if it would have come out to be 3, I would have taken the third and the fourth numbers and averaged them. If it's anything else, you force it up to the next whole number and take that one. So it's kind of nice to get a decimal, because now I can just force this up to 3. What's the third number? 19. So P25, Q1, let's just call it Q1, is 19. That's amazing. You do the next two. You do Q2 and Q3.
Wait, I don't get that. Where'd you get 19?
So we're cool up to here, right?
Uh-huh.
So what's the third number?
Okay, 19.
Yeah. So the first step is where's the answer? And the second step is go there, get the answer. Yeah. Less chance to die. Good. Ooh, worked really well. I like it. Bless you. How do you guys get Q2? You take 50% of 11, and dear God, just let this make sense. Where should the 50th percentile be? Halfway through the list, roughly. That's what the first step we do is take 50% of how long the list is. So it's not just a thing to memorize. It's a thing that makes sense. And the more you realize how it makes sense, the less you actually memorize and the more room you got in your brain. Let's see, so what's point half of 11?
5.5.
5.5, so you...
Yeah, 6.
6, what's the sixth number?
32.
32. So Q2 is 32. Bam. All right, the long way to do this one is to take 75% of 11. I think I threw you off when I said the long way. I'll show you a shortcut in a minute. 75% of 11 is 8.25, and you
Round it up to 9.
round it up to 9.
So are you always going to round it up?
Only if the result of this step is a decimal. If this would have been 8, I would have averaged the 8th and the 9th numbers. So if it's a whole number, you average that one with the next. Anything else, you round up and take that number.
Okay, so when you do average though, it's always going to be that number and the one above it?
Beautiful. Yes, and why? Because we did it. Before we even knew the process, we naturally did it with that example we did last time. That's the funny thing about the hidden behind any math formula is just a thing you would do anyway. And the formula just captures what we did so we can always do that same thing. That's all they are. Okay. What's the 9th number?
42.
42. So life, the universe, and everything. 42. Real quick. How far in did I go to find P25? I went 3 in, right? From the bottom. If I go 3 in from the top, I of course get the 75th percentile because they should be symmetric from both sides. If you don't like anything I just said, do it this way. It doesn't matter. You know, like I don't like anything you say. Yes?
On the test, do we have to like show our work?
Hell yeah. Yes. You were here, but I wasn't here last time, but I was wearing my show your work shirt. I wore it yesterday for my Math 90 students. They took their test. So I have a shirt that says show your work, so it's sort of important. It is the thing. Okay, so we got the low, the quarters, and the high. Now we can make our box plot. And this is almost too nice to believe. Something you guys have got to start to realize is scale is the most important thing in a graph. So what I always get is don't do this. Don't do this. I always get somebody to do this. 11, 19, 32, 42, and 56. There you go, Jeff. All right, well, how big is this? 8. How big is this? 13, this is 10, and this is 14. What kind of scale is that shit? No. Let's try again. I'm surrounded by erasers. Okay. So, where should I maybe start? I got to start at 11, so let's start at 10. That's a nice whole number, right? Start at 10. I got to go all the way up to 56. So let's go by 10. That scale makes sense. If I had to go up to 23, maybe by 2s would have made sense. I mean, just pick your scale. So let's see, what did I say? 10s? 20, 30, 40, 50, 60. All right. Only guy in the world that gets excited about scale. Somebody remember the weird thing we do here? We don't graph it. We do what? We don't plot a point. We put a line. So above 11, I'm going to put a line. Above, where we're going to go? 19, 32, 42, and then 56. Boom. Okay. That looks funkadelic. Is this jogging anybody's mind? I know we did a quick, this is the last thing we did last time. The middle 3, you make a box, hence the box part of the box and whisker plot. Box. And then these are the whiskers. So the book calls it a box plot. It's actually a box and whisker plot. And you can see why. Now, is it possible if you do a problem that some of these could repeat? Like this could be 19 and this could be 19. Of course, because you have a bunch of 19s in your data, so 19 could be 2 different things. Then your lines are going to overlap, and what the book does, I like it, they put a dotted line when there's 2 that are overlapping. I like it. I love you guys. You're always going to have 5 lines, but sometimes some of them might overlap. Okay, I like it. How much data is in the box? What's in the box? What's in the box? Is that reference gone, really? Yes. It's a good movie. That scene is rough, but still. So yeah, I'm not awake enough to react to you, Jeff. All right. What percentage is in that box? I love you guys. Right now you're like, how the hell would I know, Jeff? This line represents what? This line. 75th percentile, which means there's 75% below it. This line represents 25th percentile, which means there's 25% below it. So how much is in the box? 50%. That's your heartland. If you look at the Princeton Guide for Colleges and you're trying to figure out what college to go to, they will tell you the middle 50% GPAs, the middle 50% SAT scores, right? They cut out the outliers, they cut out the extremes, and they just focus on who the bulk of their students are. Okay, maybe. That's not difficult, is it? You got to know how to make percentiles. And then this is just drawing lines over some of them. Okay, all right.
Can we go over the average? Because I'm kind of confused on that.
We haven't even talked about it yet. We're about to.
Like, what do you mean by, like, take the whole
Oh!
number? I don't get what you mean
All right.
by take the average.
So let's say I do some work for P something and I get, with 11 it's not easy to do this, but let's say I had 80 things, 80 data points. How do I find P20? How do I find P anything? I just take, P20 I would take, what percentage of what? 20% of 80. We got 80 data points. What is 20% of 80? Watch this, guys. Dunk, 2 times 8 is 16. That is a whole number. So how would I find P20? I would take the 16th number and the 17th number and average them. So let's say the 16th, so here's my 80 data points. Blah, 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 blah. Here's the 16th number, and here's the 17th number. So what would P20 be? How do you find the average of 2 numbers? Here you don't really have to. You should be able to see what number's in the middle. But in general, how do you find the average of any numbers? You add them up, divide by how many there are. So if I'm just doing 2 numbers, I just have to do You do all that shit, you eventually get what you should be able to just see what's in the middle of those two. 110. And of course, 220 divided by 2 is 110. Yay! So if it's a whole number, you're going to have to average stuff. That's why I said earlier, you almost want to get a decimal, because then you just force it up and take that number, you're done with it. So you know I'm not going to let that happen on the test. Aha. Maybe once or twice. Okay, cool, yes?
So is there ever going to be a case where like you get a whole number and then you do the average and then the average is a decimal?
Of course.
So then,
All I had to do here was make this 121.
Okay, so then
And then this would have been 110.5.
at that point you just round up again?
No. That's it.
Oh.
That's it.
Oh, okay.
Cool. Okay. All right. So you just got to get in that homework and try it out. So here we go. We're going to get into, today we're going to talk about, different ways to measure center. What's the center of the data? And if I just say that, what's the first thing that comes to your mind? I got a bunch of data, I want to know where the middle is. The 50th percentile, I like it. What's another way to consider the center of data? What kind of gives me the middle somehow? Average, I love, so that's why it's measures of center. There are multiple ways to identify a center. All right? Not a Tootsie Roll center, but just a center. And now I got that commercial in it. Everybody got this stuff here? Okay, so. So we'll start off with the one that's the most commonly used, the average, which we actually call the mean. Because math people like four-letter words that start with M. So we make the average the mean. So here comes our first real formula. All the other formulas sort of not really. But here's our first real formula with Greek letters in it. Oh shit. So we just said this earlier. How do you say in English? Just tell me in English how to find the mean of a set of numbers. Add them all up. Divide by how many there are. All right. All right. So that's way too many words. So one thing math does is it replaces phrases with symbols. So just go with me for a second. And you're like, that's all we freaking do in this class, Jeff. Just say what you're going to say. What's this symbol mean? And why is the square root of 16 what it is? What is the square root of 16? 4, because why? So you understand, really this is neat because you don't even know what you did. You have taken the phrase, what does it take 2 of to multiply be the number on the inside, and you have translated into the square root symbol. You did. It's just like a foreign language. So when you see this symbol, you read it in Mathish. You don't have to translate it to English. You inherently know what it is. Anybody know 2 languages? I'm jealous. Yes? English is my second language. Math is my first. But so if you know 2 languages and you know them like really well, you don't have to translate into one of them. I have no idea what that feels like. It's probably neat. So if I try to talk in French, because it did take like a little bit of French, I have to first think in English, put it into French. I have to do that, but you guys have gotten to the point, just like the rest of us have gotten to the point with this symbol where we don't have to think, we just know what it means. I don't have to put it into English. So what's it got to do with anything, Jeff? This is what it's got to do. I don't like all this words. So add, we're going to use the Greek letter S for sum, because that's the other way to say add. We're going to use the capital Greek letter. Why are we going to use Greek letters? Because what did the Super Bowl use before? Like Super Bowl 48. What did they, let me watch the Super Bowl at all? What do they use? Super Bowl, it's not Super Bowl 48, it's Super Bowl XL. Yeah, right? They use Roman numerals and they're like in rock, this graphics, right? And of course Super Bowl 50 was L, and then they didn't do a Roman numeral. Sorry, you don't have to suddenly know Roman numerals. I'm just saying, Greek letters are just a way to put some emphasis on something, right? It's another, we use our letters already too much. We wanted to go borrow from somebody else's alphabet. So we use, this is the symbol for the Greek letter S. It's like an E that is feeling very pointy. It's like a backwards 3. It's like a whatever. Right? Oh, again, some of you guys have checked out, but good luck. All right. And add If I have a bunch of data points, what do I use to represent all of them at once? What do I use in algebra to represent something that has a lot of possible values? What is the... Yes, thank you. Okay, the variable, right? Add all up. Here. So just like this symbol, if I said do this, what would you say to me? Do this problem. What would you say to me? I love it. Yes, you would look at me like that, and you would say, of what, Jeff? You left. So this symbol by itself means nothing, just as much as this symbol means nothing. So sum up what? Sum up the x's. Sum up the data values. And then the letter we're going to use for the number of data values is n. Okay, so there's our first little equation. So let's talk about the sum symbol for a minute. So if I have these data values, what would sum of x be? What would n be? 4. N is 4. What would the sum of x be? Yeah, 3, 6, 10, right? Because again, what does this symbol mean? Add these up. Okay. Why can I add these up? Because I got them. So that's 10. Is everybody with me? So really right now we're just talking about how to translate from English to Mathish. Or in this case, from Mathish to English. What does that symbol want me to do? Add something up. What? These. Oh. So what if I ask you what this is? Now be really careful. That is not 100. If I said, what's this? What's the sum of x? 10. And 10 squared is 100. Now what is this one asking for? Cover the e. Cover the e. Do I have those? Do I have x squareds yet? I can't add them up until I get them. How do I get all the x squares? I just freaking go get them, right? So make a little x squared column. What do you get in each one of these? 1 squared is 1, 4, 9, 16. Do you guys see that? So look. You're going to have this symbol in so many equations this semester. Because a lot of statistics involves just adding a bunch of shit up. What do I want to add up? X's. Did I have them? Yes. What do I want to add up here? X squares. Did I have them? No. So I went and made them first. Now I can do what that wants me to do. What do I get when I add these up? 30. Kick ass. So what about this? How would you find this? This one right here. What would you do? Make another column. Because what does it want me to add up? Some stuff I don't know yet. So let me go see what those things are. See if I cover that, I see what column I need. I need to make a bunch of those. So then I can add them up. I'm giving you a procedure to use on a formula. Just cover this guy and see what you need to create. So what do I put here?
-1.
0, 1, 2.
Crazy. And of course, those add up to be 2. Kick in CS. Okay. That's not bad once you see what it's saying. Same way that this isn't hard once you know what the symbol is saying. Okay, so this is new to us. So we are going to have to do that silly, okay, this symbol means add. Okay, so add, I'm going to need to get these to add them. I have to do that translation in my head because we're not used to this word. This word we know. We don't have to think like that at all. We just do it. I really like pointing that out to students because you've already successfully done something like that. Just got to do it again. All right, okay, now. So we got all this weirdness I wrote here. I used to have this girl right here. She'd say, "Stop, wait." All right. So watch. We use two different symbols for population and sample mean. Population mean is a mu. Uh-oh, shit. So population we use Greek letters for. This is a U with an extra leg. Some of you guys are going to make it an M. Try not to. So let's try to draw this together. Mu, and this is like a French cow, yes. All right. Mu. All the jokes are just for me, but I like it. So mu is this. Now the book has a freaking big ass N. Gives a shit. N always means the number of things. In this case, it would be the number in my population, because a little mu means I'm talking about a population. Sample, we're going to use our letters. And here's what's really cool. I don't know. X bar is the sample mean. So they both have the same equation, of course, because they're both means. I use two different symbols just to tell me what kind of group I'm talking about. So which one would be a parameter? Say it. Which one would be a parameter? Mu. I love it. And the sample, of course, the statistic would be X bar because it's the sample. Okay. I love you guys. All right, so that's one measure of center. By the way, real quick, if I had like two sets of data, let's not make somebody die, Jeff. I did this with my other class. So say this is the number of beers you had the night before, and this is the 7 a.m. test that you took, the grade you made, right? If I wanted the average test grade from this sample, what would this symbol look like for it? Do this.
Is it the X?
No, because this is what variable? So it would be Y bar. Do you see how that works? So if I have more than one set of data, they're all going to have their own, and one's going to be X, one's going to be Y, and then I can have a Z if I want to, right? So if I want the average of these, that would be Y bar. And that would equal the sum of Y over N. So this little dude here, just like in algebra, doesn't have to be X. So that's like the most standard basic one we use. Okay, maybe. So, let me put this over here. I don't know. I need to hire a student just to turn this stupid thing. All right, that'll work. I was waiting for somebody to go, "I'll do it, Jeff." It's paying 20 cents a day. So another measure of center is something called the median. This has come up before in your homework, because all of you are doing it, so you've seen this word already. What is median another name for? Where's the median in the road? In the middle. So the median is another name for the data point that's in the middle, which is another name for what in statistics? P. If it's in the middle, it's how far through? If it's in the middle, is it 80% through? 50%, so it's P50, Q2. So the median is just P50. It's the number that's in the middle of all the data points. And it's got a symbol that looks like a mean that had a rough night. So that's the symbol for median, is X with a tilde over it. This little bar got all crumpled. Poor little dude. So how do you find the median? Well, the same way you always find it. P50, it's like 50%, you know, blah, 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 right? So where would the median be in 5 numbers? The third, right? Oh, sorry. The third one. Right? And think about it. What's 50% of 5? 2.5. If you get a 2.5, you round up to 3. The third one is, of course, it makes sense. The third one is in the middle. Ooh. What about 4 numbers? Where's the median? In between 2 and 3. Average those two, right? Half of 4 is 2. Average the second and third. That's going to be the middlest number. It's going to be the number in the middle of the 2 in the middle. All right. Nothing new there. It's just the word might be a little new. When do I use median versus mode? Mean. Mode is the next one. Let me ask you this. If I had a small company, right? I'm the CEO, I'm making $600,000 a year. And I have 3 employees, they're making $32,000, $34,000, and $36,000 a year. So it's better than what reality, but let's go with it. And I have a new employee that's coming in, and he asks, how much can I expect to make here? And I tell him the average salary. What's the average of these 3 things? Can somebody help me do that? By 4. Oh shit. 137, 20, 175? Is that it? You guys got calculators? You can help me.
78.
What is it?
78.
No.
Are you supposed to add those 3?
Add those 4.
Oh, 4.
I see what you're doing, but I'm giving the average. 175.5? Okay. That was close. If I told this dude, oh yeah, about $175,500 you can expect. Is that being honest to this guy? No. So, anytime your data has outliers, is 600 an outlier? Oh shit, yeah, it doesn't follow the pattern the other 3 do. Median is better. Median is more honest because it's not affected by the values. It just cares about the position. So what number's in the middle? What's the median here?